You know, in the world of tech, every huge challenge kind of feels like a video game's final boss. And when we talk about building artificial intelligence, well, there's this one set of problems so incredibly hard, they really are the ultimate challenge. So, what is the final boss of AI? What is that single, massive hurdle that stands between the AI we have right now and the kind of AI you see in science fiction? We're not just talking about a smarter algorithm here. We're talking about solving a problem that would change, well, pretty much everything.
And you know what? Researchers actually have a name for this category of challenge. It's called AI complete. And getting your head around it is kind of like learning the rules for the entire game of artificial intelligence.
So here it is, the official definition. A problem is considered AI complete if the only way you can possibly solve it is to first build an AI that has the same general smarts as a human being. It means there are no clever shortcuts, no narrow, specialized programs that can crack it. To win the game, you literally have to create a player that's as smart as us. To really get a grip on this, there's a fantastic analogy from computer science. See, there's this class of problems called NP-complete. And the deal with them is, if you find a way to solve just one of them efficiently, you've basically found the key to solving all of them. AI complete is kind of the same idea, but for intelligence itself. If you solve one true AI-complete problem, you've basically cracked the entire code for creating AGI.
And this idea, it's not really new. It popped up back in the 80s when the AI of the day, these things called expert systems, started to hit a major wall. I mean, these systems were brilliant at their one specific thing, but they were super brittle. The second they had to deal with the messy, unpredictable real world, they just fell apart, because they were missing what we all have, general intelligence.
Okay, so what do these legendary super hard problems actually look like? Let's step into the arena and meet the classic contenders for the title of AI complete.
So here they are, the big ones. We're talking about truly understanding language, not just the dictionary definition of words, but sarcasm, poetry, and all the stuff we say between the lines. Or seeing and interpreting the world the way a person does, or applying that massive invisible library of everyday common sense. Then you've got building robots that can actually navigate our cluttered, chaotic homes. And of course, the big one, the Turing test. Just having a conversation so natural you'd never guess it's a machine. Each one of these is a beast of a problem.
Let's start with vision. I mean, this seems so easy for us, doesn't it? We just open our eyes and see. But for a machine, it's not just about identifying pixels on a screen. It's about understanding the context, the relationships between objects, and figuring out what's actually happening in a scene. It's the difference between detecting and truly seeing.
This is just a perfect example. We've all battled these CAPTCHA things, right? You instantly know that's a stop sign, even though it's all warped and grainy. That's because you're tapping into a lifetime of experience and context. But a machine, without all that background knowledge, just sees a jumbled mess of red and white pixels. That huge gap in understanding, that is the vision problem.
All right, next up is maybe the most mind-bending challenge of them all, common sense reasoning. This is all the stuff we just know about the world. Facts so obvious we don't even think about them, let alone say them out loud. But an AI has to learn every single one of those things, completely from scratch.
And this just illustrates it perfectly. You didn't have to pull out a measuring tape or do some complex physics calculation. You just know. You understand what big means, what a doorway is, and how an elephant relates to both. And AI, without that built-in common sense, has to start from absolute zero, trying to logically piece together an answer that for you is completely effortless.
But this is where the story takes a really interesting turn. Because it turns out that the definition of an unsolvable AI-complete problem, well, it isn't set in stone. The goalposts are constantly on the move. It's this funny phenomenon known as the AI effect. Think about it like this. For decades, playing chess at a grandmaster level was seen as this peak of human intelligence. Then a computer did it, and almost overnight we all went, oh, well, that's just number crunching. It's not real intelligence. The moment we figure out how the trick is done, the magic just seems to vanish.
And you can literally watch this happen over time. Back in the 80s, people thought chess and translation were the final bosses. Then, bam, 1997, Deep Blue beats the world chess champion. Chess is basically solved. Fast forward to the 2010s, and suddenly machine translation and recognizing images get amazingly good because of deep learning. And now, today, models like GPT-4 are doing things that feel incredibly close to general intelligence, blurring the very lines we're trying to draw. Yesterday's impossible problem is literally today's smartphone app.
So, why are we even talking about this?
Why does any of it matter? Because actually solving one of these problems isn't just a cool tech achievement. The stakes are absolutely enormous.
This quote from the AI and Society journal just nails it. Solving AI-complete problems will have strong repercussions on society in virtually every dimension. Because if we solve one, it means we are right on the verge of creating artificial general intelligence. And that's going to have huge, world-changing effects on every single part of our lives.
We would immediately have to deal with these massive questions. How do we make sure an AGI's goals line up with ours? What happens to human jobs, to our sense of purpose, when a machine can do almost anything better than we can? And when a truly intelligent agent makes a mistake and causes real harm, who's to blame? These stop being fun thought experiments and become very real problems.
Now look, the potential good that could come from this is unbelievable. An AGI could help us cure diseases, solve climate change, maybe even unlock the secrets of the universe. But that immense power comes with an even greater need for caution and planning. The most important thing is this. We have to figure out how to manage this technology responsibly before we actually build it.
And that kind of leaves us with one final big thought to chew on. For decades, the entire quest has been about, can we do it? Can we solve the puzzle? But as we get closer and closer to beating that final boss, maybe the more important question we should be asking is what happens the day after we win? It's not just about solving AI's hardest problems. It's about being ready for the brand new problems its success is going to create for all of us.